Have you ever wondered how artificial intelligence has revolutionized the world of programming? It's a question that leads us into a fascinating discussion about the profound impact of AI on programming, transforming how developers craft software and systems. In the not-so-distant past, programming was a manual and time-consuming task. Developers had to write every line of code, debug each error, and perform a host of other repetitive tasks. But today, AI has brought about a seismic shift in this landscape. It has automated many of these monotonous tasks, enabling developers to focus on higher-level problem-solving and innovative solutions. AI has given rise to tools like auto-completion, refactoring assistance, and code suggestion systems. These tools leverage machine learning algorithms to enhance developer productivity, making the coding process more efficient and less error-prone. Beyond automation, AI has also made strides in the realm of natural language processing, or NLP. With AI-powered NLP, developers can now interact with code and systems using natural language. This has made it easier for humans and machines to communicate, from voice-activated assistants for coding to chatbots for troubleshooting. But the influence of AI on programming doesn't stop there. It also extends to predictive analytics, where AI algorithms analyze vast amounts of code repositories. They identify patterns and predict potential issues before they occur, helping to detect bugs, optimize performance, and improve code quality. In the realm of debugging, AI has again proved to be a game changer. AI-based debugging tools can automatically identify and fix errors in code, drastically reducing the time and effort required for troubleshooting. Moreover, AI has been integrated into programming languages and frameworks, allowing developers to incorporate machine learning models directly into their applications. This integration not only simplifies development but also enhances the capabilities of software systems. And let's not forget about personalized development environments. AI-driven integrated development environments adapt to developers' preferences and habits, offering personalized suggestions, code templates, and shortcuts. These intelligent IDEs enhance developer efficiency by streamlining workflows and reducing cognitive load. In short, AI empowers developers to write better code faster, improve software quality, and create more intelligent and adaptive systems. So, let's explore in detail how AI has made these changes possible. The first significant impact of AI on programming lies in automation. Imagine a world where repetitive tasks like code generation, bug fixing, and optimization are no longer the bane of a developer's existence. Well, that world is here, and it's all thanks to artificial intelligence. AI has played a pivotal role in automating these mundane tasks, enabling developers to focus on the more complex aspects of programming. Let's take, for instance, code generation. Traditionally, developers would spend hours, if not days, writing out lines of code. Now, with AI's help, they can automate the process, generating code in a fraction of the time. This not only saves time but also minimizes the margin for human errors. But it doesn't stop there. AI is also revolutionizing bug fixing. In the past, identifying and correcting errors in code was a tedious and time-consuming task. But now, AI-powered tools can automatically detect and rectify these bugs. This reduces the time and effort required for troubleshooting, making the entire process more efficient. Optimization, another crucial aspect of programming, has also benefited from AI automation. AI can analyze existing code and suggest improvements, making the code more efficient and effective. This not only enhances the performance of the software but also improves its quality, leading to a better user experience. Now, you might be wondering, how does AI achieve all this? Well, the answer lies in machine learning algorithms. Tools like auto-completion, refactoring assistance, and code suggestion systems leverage these algorithms to learn from past data and make accurate predictions. They can suggest the most appropriate code snippets, refactor existing code, and even predict potential bugs. Auto-completion tools, for example, can predict what a developer is trying to type based on the initial characters in the context. This not only speeds up the coding process, but also reduces the chances of syntax errors. Refactoring assistants, on the other hand, can suggest ways to improve existing code. They can identify redundant code, suggest more efficient alternatives, and even detect potential performance issues. Lastly, code suggestion systems can provide developers with recommended code snippets based on the current code and past patterns. This can save developers from having to recall complex code structures, making the coding process smoother and faster. In essence, AI has transformed the way developers work, making their lives easier and their work more efficient. It has taken over the repetitive tasks, freeing up developers to focus on what they do best, creating innovative solutions and pushing the boundaries of what's possible. And remember, this is just the beginning. As AI continues to evolve, so will its impact on programming and automation. We can look forward to a future where AI not only automates tasks, but also enhances creativity and innovation in programming. With AI, developers can now automate tedious tasks, boosting their productivity. AI's influence extends to natural language processing in programming. This is a profound statement that unravels the depth of AI's impact on the way we communicate with machines. Imagine being able to converse with your computer or a software system using the same language you'd use to chat with a friend. That's the power of AI-powered natural language processing, or NLP for short. NLP in programming is all about enhancing the human-computer interaction, making it smoother and more intuitive. It's like having a conversational partner in your coding journey, a partner who understands your language and responds in kind. No longer do you need to rely solely on complex codes and syntax. Instead, you can leverage natural language to instruct, query, and even troubleshoot your systems. Let's dive into some examples to illustrate how AI-powered NLP is revolutionizing programming. First, consider voice-activated assistants for coding. Yes, you heard it right. Voice-activated assistants akin to your everyday Siri or Alexa, but these ones are specially designed for coding. With these assistants, developers can dictate code, ask for code suggestions, and even debug their code using voice commands. This hands-free coding experience not only brings convenience but also enhances productivity, especially for developers with physical disabilities. Now let's talk about chatbots for troubleshooting. We've all been there, stuck with a code error, scrolling through endless forums for a solution. But what if you had a chatbot that could understand your problem in natural language and provide targeted solutions? AI-powered chatbots can do just that. They can understand the context of your queries, sift through vast repositories of documentation and forums, and offer precise solutions. It's like having a personal assistant who's always ready to help you out with your coding issues. But how does all of this magic happen? How does AI-powered NLP understand and respond to natural language? The answer lies in machine learning, a subset of AI. Machine learning models are trained on vast amounts of data, learning the patterns and nuances of natural language. These models can then interpret natural language inputs, process them, and generate appropriate responses. It's a complex process, but the result is a seamless and intuitive interaction between humans and machines. The benefits of AI-powered NLP in programming are monumental. It makes coding more accessible, especially for beginners who might find traditional coding intimidating. It enhances productivity by automating repetitive tasks like searching for solutions to common errors. And most importantly, it fosters a more inclusive programming environment, where anyone, regardless of their coding skills or physical abilities, can contribute to the creation of amazing software. To sum it up, AI's influence on natural language processing is truly transformative, breaking down the barriers between humans and machines. It allows us to interact with code and systems in a way that feels natural and intuitive. AI has made it easier for humans to communicate with machines, simplifying coding processes. As we forge ahead into the future of programming, AI-powered NLP will undoubtedly play a key role in shaping the way we build and interact with software. Another game-changer in programming is AI-powered predictive analytics. You've probably heard of predictive analytics in a variety of contexts, but what does it mean in the world of programming? Well, it's all about patterns. In our daily lives, we constantly recognize and interpret patterns, and it's no different in programming. The difference is that AI algorithms can analyze vast amounts of code repositories, much more than a human could ever hope to comprehend, to identify these patterns. This deep analysis is not limited to the structure of the code, but also extends to the behavior of the software while it's running. The AI studies how the software behaves under different conditions, what kinds of inputs lead to errors, and what parts of the code are most prone to bugs. It's like having a super-powered detective on your team, tirelessly combing through every line of code, every output, every error log, to find clues about potential issues. But what's truly revolutionary about predictive analytics in programming is that it's not just about identifying existing problems. It's about predicting potential issues before they occur. Imagine being able to catch a bug before it even happens, or knowing that a certain piece of code is likely to cause performance issues before it slows down your application. It's like seeing the future of your software, allowing you to prevent problems instead of just reacting to them. This predictive power is particularly useful in complex, large-scale software systems where even small issues can have significant impacts. By identifying patterns in the code, predictive analytics can highlight areas of the codebase that are more likely to harbor bugs, or parts of the software that are most vulnerable to performance problems. This allows developers to focus their efforts where they're most needed, optimizing their time and resources. Another key benefit of predictive analytics is its impact on code quality. By identifying patterns in high-quality, efficient code, AI can suggest ways to improve the rest of the code base. It's like having a mentor who's analyzed millions of lines of code from the best programmers in the world, offering you insights and suggestions to make your own code better. But it's not just about finding bugs and improving code. Predictive analytics can also help optimize performance. By analyzing how the software behaves under different conditions, AI can predict how changes in the code will affect performance. This allows developers to make informed decisions about how to optimize their code, leading to faster, more efficient software. In conclusion, predictive analytics is a powerful tool in the programmer's arsenal. It's like having a crystal ball that can see the future of your code, helping you catch bugs before they happen, improve code quality, and optimize performance. Thanks to AI, developers can now foresee and prevent bugs, optimize performance, and improve code quality. AI has also transformed debugging in programming. This change is a real game changer, as debugging can often be one of the most time-consuming and frustrating parts of a developer's job. Intelligent debugging tools powered by AI are here to help. These tools are smart enough to automatically identify and fix errors in code, drastically reducing the time and effort required for troubleshooting. Imagine the hours saved when a machine can do in seconds what used to take a developer hours, or even days to accomplish. So, how does it work? These intelligent debugging tools use a variety of AI techniques, including pattern recognition and anomaly detection. Pattern recognition allows the AI to understand the structure of the code and to identify common mistakes. The AI learns from the vast amounts of code it processes, becoming more accurate and efficient over time. AI is not just a tool for programmers, it's becoming a part of programming languages and frameworks. Once upon a time, integrating machine learning into an application was a complex task, reserved for those with advanced degrees and specialized knowledge. However, the landscape of software development is changing rapidly. Today, thanks to the integration of artificial intelligence into programming languages and frameworks, developers are now able to incorporate machine learning models directly into their applications with relative ease. Think of it this way. Imagine you're building a house. You could make your own bricks, painstakingly crafting each one by hand. Or you could buy pre-made bricks, saving time and ensuring a higher standard of quality. Similarly, pre-integrated machine learning models are like those pre-made bricks. They enable developers to construct robust AI-powered features without needing to engineer every single component from scratch. But what does this actually look like? Let's delve a little deeper. Many modern programming languages now come with libraries and tools that simplify the process of integrating machine learning. For instance, Python, a language known for its simplicity and readability, offers libraries like TensorFlow and PyTorch. These libraries provide pre-trained models and high-level APIs, allowing developers to incorporate complex machine learning functionalities with just a few lines of code. Similarly, JavaScript, a language primarily used for web development, offers libraries like Brain.js, which enable developers to integrate neural networks into web applications. And let's not forget about Swift, which in partnership with TensorFlow has introduced a powerful toolset for machine learning known as Swift for TensorFlow. Moreover, it's not just programming languages that are embracing AI. Software frameworks, which provide a standard way to build and deploy applications, are also integrating machine learning capabilities. For example, the popular web framework Django has extensions that allow developers to incorporate machine learning functionalities into their web applications. What does this mean for developers? It means that they can now leverage the power of machine learning to build smarter, more interactive, and more responsive applications. They can create applications that learn from user behavior, that predict user needs, and that adapt over time. They can build systems that can understand natural language, recognize patterns, and even make decisions. However, it is important to remember that while these tools and libraries simplify the process of integrating machine learning, they do not eliminate the need for understanding the underlying principles of machine learning. Developers still need to know how to choose the right model, how to train it, and how to evaluate its performance. In conclusion, the integration of machine learning into programming languages and frameworks is revolutionizing the way we develop software. It is making machine learning more accessible, more usable, and more powerful. It is enabling developers to push the boundaries of what is possible with software, and in doing so, it is opening up new possibilities in application development. The integration of machine learning has opened new possibilities in application development. AI is personalizing the programming experience. This statement rings true today more than ever. As we delve into the world of AI-driven integrated development environments or IDEs, we are met with the realization that programming is no longer a one-size-fits-all scenario. AI has the ability to adapt, learn, and grow. It can understand a developer's preferences, habits, and even their unique coding style. This deep understanding is then applied to create a development environment that is truly tailored to the individual developer. Imagine an IDE that evolves with you. It understands your coding habits and anticipates your needs. For instance, if you frequently work with a particular library or use a specific coding pattern, the IDE learns this and offers you personalized suggestions. It might even suggest code templates or shortcuts that align with your routine, making your coding life easier and more efficient. But it doesn't stop there. These intelligent IDEs take it a step further by streamlining workflows. They can identify repetitive tasks and offer to automate them. They can flag potential issues before they become a problem, allowing you to address them early on. This reduction in manual and repetitive tasks frees up mental space for developers. They can focus more on the creative and complex aspects of programming and less on the mundane. This is particularly beneficial for large projects where the cognitive load can be overwhelming. An interesting aspect of these AI-driven IDEs is their ability to learn continuously. As developers evolve, so do their preferences and habits. The IDEs keep pace with these changes, continuously offering personalized suggestions and streamlining workflows. In other words, the more you use them, the smarter they get. In essence, these intelligent IDEs are like personal assistants dedicated to making your coding life easier and more efficient. They learn from you, adapt to you, and work with you to create a personalized development environment. But what does this mean for developers? It means increased productivity. It means less time spent on repetitive tasks and more time for innovation. It means a development environment tailored to your unique needs and preferences. It's clear that AI is changing the face of programming, making it more personalized and efficient. But it's not just about making life easier for developers, it's about empowering them to create better software faster. In the grand scheme of things, this personalization and efficiency translate into more innovative software systems and applications. It paves the way for a new era of software development where AI and developers work hand in hand to create solutions that were once thought impossible. AI-driven IDEs are streamlining workflows and enhancing developer efficiency. As we move forward, it's exciting to think about what the future holds for AI and programming. One thing is for sure, the programming landscape is evolving, and AI is playing a pivotal role in this transformation. AI is taking software testing to the next level. It's a bold statement, but one that holds a lot of truth. The advent of AI has revolutionized the way we approach software testing, enabling the creation of sophisticated testing frameworks that automate the generation of test cases, analyze test results, and prioritize testing efforts. Let's start with the generation of test cases. In the past, this process was manual and often time-consuming. It required a deep understanding of the system under test and a keen eye for potential failure points. But with the help of AI, we can automate this process. Machine learning algorithms can analyze the software, learn from its behavior, and generate a broad range of test cases that cover various scenarios. This not only saves time, but also ensures a more comprehensive and thorough testing process. Next up is the analysis of test results. With traditional methods, analyzing test results could be a tedious task, especially when dealing with large and complex systems. However, AI has changed the game here too. It can sift through the vast amount of data generated during testing, identify patterns, and pinpoint potential issues with remarkable accuracy. This allows developers to quickly identify and address problems, significantly reducing the time spent on troubleshooting. But AI doesn't stop at generating and analyzing test cases. It also helps prioritize testing efforts. Let's face it, in a real-world scenario, it's impossible to test every single aspect of a software system. There's simply not enough time or resources. That's where AI comes in. It can analyze the code base and identify areas that are more prone to errors or have undergone recent changes. This way, testing efforts can be focused on these high-risk areas, ensuring that they are thoroughly vetted and free of bugs. So, what's the big picture here? Well, AI is making the testing process more efficient and effective. It's enabling us to do more with less and ensuring that the software we produce is of the highest quality. It's helping us catch issues earlier in the development cycle, reducing the cost and effort required to fix them. And most importantly, it's making our software more reliable. In a world where software is increasingly becoming a part of our daily lives, reliability is key. We depend on these systems to perform a myriad of tasks, from the mundane to the critical. A bug or a failure could have significant consequences, disrupting our routines or even putting lives at risk. That's why it's so important to ensure that our software is thoroughly tested and free of defects. And thanks to AI, we're better equipped to do just that. Automated testing has made the software more reliable and the testing process more efficient. This is the power of AI in software testing. It's transforming the way we ensure the reliability of our systems, making our lives easier and our software better. And as AI continues to evolve, we can only expect this trend to continue. One of the most exciting developments in programming is the advent of self-adaptive systems. This is a new breed of software systems that are smart enough to adapt to their environment. Imagine a system that can adjust its behavior and configuration in real time, responding to changing conditions and requirements. That's exactly what we're talking about here. Self-adaptive systems are designed to be flexible and resilient. They leverage artificial intelligence to monitor their environment, assess the situation, and make decisions on the fly. This is particularly useful in dynamic environments where traditional programming approaches may be insufficient. For example, a self-adaptive system could be a traffic management system that adjusts traffic light timings in real time based on the current traffic conditions, or a power grid system that automatically balances power loads to prevent outages. But how do these systems actually work? At a high level, self-adaptive systems use feedback loops to monitor their performance and environment. They then use AI algorithms to analyze this data and make adjustments. These adjustments could be anything from tuning performance parameters to changing the system's behavior to even modifying the system's structure. This is where artificial intelligence comes in. AI algorithms are used to analyze the data collected by the system, identify patterns, and make decisions. These algorithms could be based on machine learning, where the system learns from past data to make future decisions, or they could be based on rule-based systems, where the system follows a set of predefined rules to make decisions. The beauty of self-adaptive systems is that they can learn and improve over time. As the system collects more data and experiences different situations, it can learn from these experiences and make better decisions in the future. This learning process can be supervised, where a human operator provides feedback to the system, or it can be unsupervised, where the system learns on its own. Self-adaptive systems also have the potential to greatly improve system reliability and performance. By constantly monitoring their environment and making adjustments, these systems can avoid problems before they occur, react quickly to unexpected situations, and optimize their performance to meet changing demands. However, building self-adaptive systems is not without its challenges. These systems are complex and require sophisticated AI algorithms. They also require a deep understanding of the system's environment and the potential changes that could occur. Despite these challenges, the potential benefits of self-adaptive systems make them a promising area of research and development. Self-adaptive systems are a testament to the adaptability and intelligence that AI brings to programming. As artificial intelligence continues to evolve, we can expect to see more and more self-adaptive systems that can adjust and adapt to their environment, making our software systems smarter, more resilient, and more efficient. AI has already transformed programming, but this is just the beginning. As we look to the horizon, we can see that artificial intelligence is set to revolutionize programming even further. The integration of AI in software development is not a matter of if, but when, and the when is now. It's a thrilling time to be a developer as the landscape of programming is rapidly changing, becoming more dynamic, intelligent, and efficient. Let's start by considering automation. Already, AI is automating repetitive tasks, boosting developer productivity, and enhancing code quality. But we're only scratching the surface. Picture a future where AI not only suggests code but writes substantial portions of it, freeing developers to focus on more complex and creative tasks. Imagine AI systems that can learn from each developer's style and preferences, adapting to provide personalized code generation. Next, let's delve into natural language processing, or NLP. As AI becomes more proficient in understanding and generating human language, it will enable more intuitive interactions between developers and their tools. In the future, developers could describe what they want to do in plain English, and AI could translate that into code. This could make programming more accessible and inclusive, opening the field to those without traditional coding experience. Predictive analytics is another area where AI is set to shine. Today, AI algorithms can analyze code repositories to detect patterns and predict potential issues. But what if these algorithms could predict not just bugs, but also future requirements and features? They could anticipate changes in user needs or market trends, enabling developers to stay ahead of the curve. Intelligent debugging is another exciting frontier. AI-based tools that can automatically identify and fix errors will become even more sophisticated. They might even be able to anticipate errors before they occur based on the patterns they've learned from millions of lines of code. This could dramatically reduce the time and effort developers spend on troubleshooting. As for machine learning integration, we foresee a future where AI is not just a tool for developers, but an integral part of the programming languages and frameworks they use. Developers will be able to incorporate machine learning models directly into their applications with ease, creating software that is more intelligent and adaptive than ever before. We also expect to see more AI-driven personalized development environments. These intelligent integrated development environments, or IDEs, will adapt to each developer's unique habits and preferences. They'll offer personalized suggestions, code templates, and shortcuts, streamlining workflows and reducing the cognitive load on developers. AI will also revolutionize testing. Sophisticated AI-enabled testing frameworks will automate the generation of test cases, analyze results, and prioritize testing efforts based on code changes and potential risks. This will speed up the testing process and ensure software reliability. And let's not forget self-adaptive systems. AI-driven systems that automatically adjust their behavior and configuration in response to changing conditions will become the norm. They'll be able to respond dynamically to user needs and environmental changes, outperforming systems built with traditional programming approaches. In conclusion, the future of programming with AI looks incredibly promising. We can anticipate a world where AI not only assists developers but collaborates with them, learning from their expertise and enhancing their capabilities. As AI technologies continue to evolve, the future of programming looks more exciting than ever. So buckle up, because we're in for an exhilarating ride.